All right, so number 11 is very similar to number 9. The only difference is that they're going to be asking for an angle instead of a side. But let's just start by sketching out our triangle again. And we're making the assumption that it's not going to be a right triangle. So let's see what happens. Again, as far as labeling, it doesn't matter, A, B, and C. Just remember that capital letters represent angles, lowercase represent sides. So if this is big A down here, meaning angle A, then that means that would be little a. If this is big B, that means that's little b, and big C, that means that's little c. And then let's just go to label everything. So they tell us that angle C is 35, and they tell us that little c is 27. So that means the side of that triangle is 27. And they tell us little b is 47. And then what it says is it says find big B, right? So that would be angle B. Well, so remember we use theta when we don't know what an angle is, so that's kind of our unknown. And then we just want to see, well, who pairs up with who here. So it looks like that B, I don't know what angles B is. I do know what his side is. His side is 47. I just don't know what his angle is, so we'll just say sine of theta. And then the other one that I can pair up is going to be C, because I know side C, which is 27, and I know angle C, which is 35. And then so up to this point it looks pretty much the same as the last problem, so we're gonna cross multiply. So I've got 47 times sine of 35 degrees, and we're going to cross multiply the other side. So I've got 27 times sine of theta. Now, so I'm trying to get theta by himself, and so getting theta by himself, I've got to first of all get rid of this 27. So I'm going to divide both sides by 27, and then I'm just going to flip it around here. So we'll say sine of theta is equal to 47 times sine of 35 divided by 27. Now theta is still not by himself, so we got to get rid of the sine. So this becomes like what we did on number 7, where we were just solving for theta. So remember we said we use inverses to find angles. So the opposite, or the inverse of regular sine, would be sine to the -1. Well, in this case, we're talking about sine as well. So this would be the inverse. And so regular sine with the inverse of sine, those two guys cancel each other out. And then so what we're left with is just theta. But then what we do to one side, we have to do to the other. So, and it's actually this whole thing. So sine of to the -1 of, and it's this whole chunk here, this 47 times sine of 35 over 27. And then so we'll go into the calculator from there. So start with the inverse of sine first, and then we've got 47 times sine of 35 divided by 27, and we'll close all that off, and we got an error. So if you get an error, so we'll hit go to. Oh, I think we left off a parentheses there. Nope, we still didn't like that. If you notice the parentheses here, let me retype that. So sometimes with the TI, he's kind of picky about how you type this stuff in here. So I've got 47 times sine of 35. So what I didn't do is I didn't close off the parentheses there for sine of 35. So 47 times sine of 35 divided by 27, and then we'll close the whole thing off. And there we go, we worked that time. So we get 86.8, so we can round that to approximately 87 degrees. So again, and that is a degree measure, so this is certainly not drawn to scale, so at an 87 degree angle that would be a little bit bigger, but again, this was just our sketch.